Hey everyone, welcome to Live App Review. I'm Matt with Near Protocol, and I'm going to show you how to use a boilerplate repository that I've been working on as a starter for a project where we are going to drop social tokens to users without requiring them to have Near first and pay for the gas themselves. So what we're going to do is we're going to take this repo here, the Near app boilerplate, and we're going to modify the contract to basically drop some fungible token, but we won't be using any standard. So we're just going to maintain a ledger of account IDs and balances. Actually, in the beginning, it's going to be public keys to balances of these tokens. And then we're going to allow the user to transfer the ownership of these tokens to an account ID. So again, this is live app review. So the contracts are going to be not good, but we'll eventually start using standardized contracts. But what we're going to show off is more about the app UX and the interactions between the front end Near API.js and a backend Node.js server to basically be able to do a social token drop to a bunch of followers on Twitter, for example, but without basically requiring them to have a Near wallet or Near tokens in order to claim them. So I'm going to show you how that works. First, we're going to clone the repo. And I've got my, that's not it. I've got my environment here. Got a bunch of files open. I'm just going to close them all so I know where I'm starting. I'm in my Near directory, so I'm going to git clone the Near boilerplate. But I'm going to clone that into a new project called, I'll just call it like social drop. So then I'm going to go into social drop. So this is also an example. If you were going to use this Near app boilerplate, this would be an example of you cloning this repository for the first time into, my dash project and then starting your own app. So I'm going to show you how I would sort of interact with this repository. So the first things first is, let's install everything, obviously. So I'm just using Yarn here to install everything. I'm going to also add the folder at the same time to my workspace. So I can just browse through social drop here. I'll make my screen a little bigger for everybody. Okay, so everything's installed and I know what's in this repo, and you should read the README as well. So you should go into the server and install all the files in there. So the server is kind of like, it's a mono repo, but basically the server has its own dependencies. So you're going to want to install that as well. So that's pretty fast because there's nothing really in there. You can start the server though. So yarn start. So that starts the server running, and then let's open up another terminal here for social drop. And let's go yarn start on the actual app itself. So this is, again, just the Near boilerplate. If everything went well, which I'm assuming it didn't, never assume it went well. But it's probably building from scratch, so it's going to take a while. Oh, wow, it did go well. Fancy that. Wink, wink. It's like I haven't been working with this boilerplate for weeks trying to get it to be, relatively robust. I could go through and test this, but if you want to know what the actual boilerplate does, just like out of the box, it's just this like cool access key example where you can basically have users create like a message string, kind of a quote NFT, but not a real NFT yet. And then they can sell it, and based on the access key, they can earn Near without actually having Near because the app is paying the gas fees. So check that out. The video is live contract or live app review #1, basically access keys. But in this one, what we're going to do is we're going to jump straight to editing the contract, and I mentioned that the contract's not going to be pretty. So I'm going to go do I'm going to stop that app. I just wanted to make sure that everything ran. I'm going to do a real hatchet job on this contract now. And so again, let's think about the problem here. So think about the app we're trying to build. I want users to come to my website and I want them to authenticate with some service. Let's call it Twitter. I want to drop them social tokens based on a key pair that they generate, probably in the browser. So I'm going to store that in local storage. And then at some point in time, I want them to be able to transfer those tokens to a near account that they own. So I'm going to need to keep track of tokens inside this contract that both belong to a public key, and it should be a public key that's added to this contract. So that's going to be an access key added to the app contract by the server. So I don't really need to worry about protecting against random public keys, random access keys calling methods on this contract. Let me just think. Yeah, I don't, because I can check. I do need to actually do that in the contract. I can check the signer account ID is the predecessor account ID, so it's the contract itself. And I can also check the signing public key and then assign the token drop to them. So let's work on the first part, which is basically dropping tokens to a public key that should have the account ID of this contract itself. So I'm just going to make it tokens. No, I'm going to call this, I called my project social drop, so I'll call that social drop. Actually, I don't even need another struct, so I'm just going to I'm not going to make anything complicated here. I'm just going to do it in the actual contract itself, but without like an additional, I don't need like structs and structs. So basically, I'm going to say, let me think about this. Yeah, because I'm going to have to work on part 2 eventually. So I'm going to do it, like, I'll call this drops. Actually, I'll call it dropped. It'll make more sense. And then I'll call this tokens. And I'm going to basically make account ID and public key. And then these are going to map to, I'm just going to stick with the JSON type that we have in near. I think that'll keep it simple, but I may come back and change this. So when I owner ID, I can just leave all that. That's fine. When I go create this contract, I need to initialize the storage here. So I'll just do that really quick, and that should be fine. Okay. So now we got a function called drop. Well, we do now. I'll leave the viewable function. There's not going to be a payable function. Nobody's going to pay for anything here because they're just getting a free drop. So again, it's going to be a very, really nasty basic contract. So just bear with me. So the drop is going to go to the signing account key. We do want to make sure that the signer account ID equals the predecessor account ID. Now, why is that? Because the access key that we're going to add is going to be equal to the or the account ID of the access key that we add is going to be, I want to make sure that's right. Just a sec. Can't walk and chew bubblegum at the same time. Okay. So the access key, the public key that's going to actually like call the method to get the drop is from the user. The user has the secret key. The app shouldn't have the secret key. I mean, but it's going to be stored in the front end. But let's try to forget about that for now. And then the app is going to add the key as an access key to its own account by way of a server. And then it's gonna allow the user to call this drop method. So the user is going to call drop. And then that public key is going to get those tokens. And then what we're going to do is we're going to have another one called transfer. And we're going to transfer to some account ID. So it's still going to be the user's public key that's calling it. And then it's going to call account ID. It's not going to return anything. But let's finish off drop first. So we check to make sure the drop's okay. And then what we do is we have to make sure that, I'll just copy this for now. I'll just say, check the balance of the drop probably. Dropped, get public key. Let's just check it. And then if we're calling drop, we want to assert equals that balance equals 0 because we don't want to drop too much to one person. Yeah, and since we're going to store the JSON type because we're going to return the JSON type. So let's just, oh, I had my view method there. That was a view method. Oh, man, I'm making a mess here. That's going to be transfer, and this is going to be get balance. Sorry about this. Public key into. This is going to be a public key. Whoops. Going back. So we're going to return the balance, and we're going to spec balance tokens. So self dropped get balance. We probably want, actually, just for safety's sake, get balance dropped, get balance tokens. Again, this is not going to be standard by any means. This is not the part that I want to focus on, but it's going to take time, so sorry about that. Account ID. Okay, so account ID into expect no tokens. All right, so okay, should be fine. So now we got drop, and then we got transfer. I still haven't actually dropped the token, so as long as the balance equals 0, so if it doesn't panic, balance is going to be so token already dropped. I'm just going to unwrap OR into 0 here. So if it doesn't find it, it's going to be 0. And then I'm going to panic if it's not 0. I don't know. You might have a better way to do things, Eugene. Wink. All right. Balance plus equals. So we need a const here for some drop amount. So I don't even remember how to do a const there. Drop amount. Probably not putting semicolons anywhere. Yeah. All right, it's gonna scream at me. All right, return. Everything's U128 capital U for our JSON type. Balance plus equals drop amount. Oh, we could just do balance. Oh, we don't even need to do that. Okay, so we're just gonna do self dot dropped dot set that in. I think probably no, we're borrowing. I don't think we want to do anything weird like that. So that's the drop. And then we have to make sure that we can also, so that key has to be part of the contract. So we check that on the drop. Now on the transfer, we still have to check the predecessor account ID. So let's just copy everything. It's going to be a lot of the same stuff. But in this case, we're checking that the balance is not 0. So I don't even know how that works in Rust. Okay. let's hope that works. Okay. Okay. So we remove from the public key, we remove the drop tokens. It's going to allow them to get the drop again, but so let's skip it. Let's not worry about cleaning up contract storage. Let's just transfer the tokens. Actually, it does make sense, but you'll have to protect against them not getting the drop again. Or maybe the drop runs out. I don't know. Then self.tokens set. So we want to transfer the tokens to the account ID that the person passes in. And we're not even going to take an amount. We're just going to transfer all the tokens. So, yay. Transfer tokens to, and it's still drop amount. Let's see. We'll take the balance of it. So balance is not equal to 0, otherwise no tokens. Remove it from the drop at the public key index, the one that's signing this transaction, and then self.tokens.set, move the balance over to the account ID. So again, not a perfect contract. We are going to basically drop tokens to a public key, and then we're going to allow that public key to sign a transaction that will move those tokens to an account ID. We have 2 change methods after we initialize our contract, and we have 2 view methods to basically check the balance dropped and the balance tokens. That's it. So drop, transfer, check. Let's do a couple of tests here. I'm just going to clean up a little bit here. Always go back and make some unit tests. So get the signing PK. So we're going to sign with some PK, let mute contract messages. It's not messages anymore. What did I call it? I called it social drop. Yeah. So got to fix all this. Okay, cool. Here we go. Just do that anyways. So contract.create. Okay, so not create anymore. Contract.drop. So we're going to drop to someone. No arguments, I think. Yeah, no arguments on drop. So we're going to drop, and then we're just going to check. Yeah, we want to get balance dropped. And we'll feed it. So we should be able to ask it about anyone, not just ourselves. So we should. Yeah, let's do this. I think that'll be okay. Balance is out. Yeah, comment that out for now. Okay, so now that our contract's written, only took like 20 minutes. This might be a 2-parter, but I hope I can get to some app stuff. Test unit, assuming it's all going to fail, because I am not a Rust expert, but anything else? Think about it. Oh, might be nice if that actually equals something. drop amount was not set. That's a const. It should be set throughout. Holy. Okay. Oh, doesn't like that assert not equal, even though it looks like it did. I think you can do that. I'm gonna have to look this up actually. Oh, let's see. Ah, assert NE. Nice one. One restation. All right. Few more errors to go through. We did a lot of changes, so not surprising. Public key. Okay, so some stuff's not set in the scope. Oh, signer PK. Let's just change it to public key. That makes it easier. Makes all the stuff the same. Okay. And you can see how I debug. Okay. What? Doesn't like set? Hang on one sec. Just looking at another contract here. Insert. Ah. Okay. So happens to everyone, I bet. No. I don't know why set doesn't. That sounds cool. Okay, we're getting there. A lot of this stuff has to do with this U128 stuff. Oh, yeah, it's everywhere. Mm-hmm. 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 Actually, you know, instead of panicking, probably gonna make my app a little better if we just that. Okay, so oh, okay. It wants a reference. Oh boy, oh boy, oh boy. Oh yeah. My rest really likes to talk about it. Okay. I think that was a mistake. Turning it into the JSON type. Okay, calm down. That might be it. No, no. Oh yeah. Oh boy. Where's the Some borrows. Classic borrow errors. Public key was used probably like 15 different places. You know if you need that in. Everything. Oh boy. But guess what? Failed the test. Okay, so compiled. Only took 5 minutes to get through my nasty rest. And we failed the test. Why did we fail the test? Oh, who's this? That is not even the right. Oh, wrong error. There and there. Oh, there's something wrong with the drop. Oh yeah, this assertion failed. Okay. So app key not contract. Same error. So this is a quick fix. So we need to make sure that the public key coming from the app, so current account ID, signer account ID. Yeah, we just need to make sure that this is the same. In our app, it's always going to be the same person. So it'll just be like alice.testnet released the contract. Okay, so that test passed. We got the drop amount, and now we're going to try to transfer the drop amount, and we will transfer it to a different account. We'll just like pass in some account name. So we're going to do a drop, and then we're going to do a transfer. Then we're going to go get balance tokens. Probably got to do a bunch of rest. Oh boy. It's fun. All right, so make sure that that transfer works. Okay. Whoa. Now we're really doing well. Let's do one where we panic because we don't do, well, we already saw that the not, I can even uncomment this. We saw that the not contracting works. So what should we try to do? Let's try to double. Drop happened already. Let's try to drop with the same person, and that should panic. Panics, then the test is true. Drop happened, but it expects to say token. So the panic should panic like that. All right, cool. And then let's try to transfer to old Bobby. Everybody knows the story about Alice and Bob, the cryptography guinea pigs. Something happened. I don't know. So panic. Oh, that's a double name. Panic. Call this test. Panic transfer no drop. So this Alice or whatever doesn't have any tokens. This is panic double drop. All right. Cool. Okay, and go. Panic, transfer, no drop, blah, 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 blah. You don't like me. Token's already dropped. That's what it's expecting. That's not what it said. Oh, that is what it said. Expected string, blah, blah, blah. Not very helpful commentary, huh? Okay, what happened? No tokens. That's it. Panicked because the person trying to transfer had no tokens. Okay, so our unit tests are done. So let's move on to some app tests. All right, so here we have this deploy contract. So this is under the, we're done, by the way. We're done with Rust. We're done with the contract. I think it's going to do what I want it to do. So now we're going to move on to the app tests. So app tests are in the test folder of the root directory of Social Drop. I'll upload the repo later. Basically, everything's in the contract, so we don't need anything. We just need to create one of these key pairs, these access keys, and we just need to drop tokens. So let's check a drop for Alice here. First of all, I'm going to comment out these other tests. Let's check a drop. Let's comment out this one too. This just checks that the contract was deployed, but pretty sure it's going to happen. Okay, so we're going to check dropping tokens to Alice. So Alice is going to check the drop, and there's no args. No args. No args. Then we're going to get the access keys, and we're going to get dropped tokens. No, get balance dropped for public key, access keys, public key. Talk like a robot all day long. Expect this to equal, what do we say it was? Okay, it's just like 100. So it's 100 tokens. So let's put that here actually. Out. All right, and let's put it here. Okay. That's actually going to be just the value. So expect balance. Actually, one other thing we have to do before we can run any tests is we have to check our config. And I'm going to shut down that server because that server is not going to help us with the app test. So why do we have to check the config? Because we need to change these methods. We need to change these to drop, transfer, get, balance, dropped, get, balance, tokens, tokens. All right, cool. So blah, blah, blah. The rest is fine. That dev account's going to change when we run test deploy. Then we're going to basically come through here. So if we run yarn test : deploy, we're going to deploy the contract. We're going to run through this test against the contract. We've already done the unit tests. They worked out okay eventually. And then we're going to basically check the drop functionality against Alice's public key. So Alice is the one signing this method, but Alice is also the contract owner. So that's not too interesting, but we should just check it for our own sanity before we move on. Okay, so let's test deploy. So we need to deploy the contract. Oh, I can only spell it. So we should be compiling like a new WASM contract. And then, I think it's like, is that multi-threaded? Something like that. So that's compiling. So I'll just keep writing tests, I guess. So just go down here. Let's just copy kind of what we did here, but instead we're going to create a key pair. Public key, We got Bob's public key and implicit account ID, which we'll tackle that later. Bob's public key is going to be here. Implicit account ID don't need. Something's going on. Oh boy, it's deploying. Going to do that first test. Actually, see, I can't wait to see how it fails. Everything fails. Come on. Oh yeah, it failed spectacularly, actually. Cool, cool. Let me come back to this Bob test. I'm just gonna paste in the drop stuff here. We will need to get a access key account for Bob. Get a contract in Bob. The rest I'm gonna have to clean up in a sec. Just make sure when I uncomment this, I am coming back to something half decent. Okay, so comment out that. So let's figure out why the first test, Alice drop didn't work. Function call panicked. Failed to deserialize input from JSON. What? Oh. Get bounce dropped. Come on. Let me think. Expected a C. Oh. Uh-oh. How did I do this in the other con? Go take a look here. I think in the other contract, I was getting the balance of the balances based on a public key call. Get message. That's why. So we got to update the contract. JSON type public key. Want to make sure that we can pass in a public key from JavaScript. So recompile the contract. So the reason why is because public key expects the public key that you get from access keys here is like a string, like an ed25519 : some base 58 encoded key. And so the contract needs to accept that public key as a base 58 type. Oh, and now we got 100 as a string. Okay, we're close. Expect. Blah. Probably should put the base line number. Oh, I'm still doing test deploy, but when I edit the JavaScript test, I don't actually need to redeploy the contract. So that is kind of like wasting time. But it's okay. So next time I'm just going to run, check drop, it passed. Woo! Okay, so almost done writing the test. So now public key of Bob, public key. So that actually could just go in like that. So, okay. So the first test, Alice, she was the owner of the contract, and she asked for drop tokens, and she got them. But that's because, her public key was, her public key is valid for a drop. Now Bob is going to ask for a drop too. So Bob's going to ask for drop tokens. But what's really important here is that Bob is not a near account. Bob is just a key pair. So Bob created a key pair in his browser. And Bob is now this access key account, which, by the way, I'm going to have to store that account. So I'm going to actually get rid of the const here. So Bob is this access key account. Okay, so Bob's just floating around as some key pair. The key pair gets added to the contract, which I haven't done. Let me just double check here against the, see how useful this boilerplate is? Let me double check against the app test here. I think you need to add the key to the account. Yes. So acting as the contract account, we're going to add the Bob key. So first we create the Bob key pair and we store some stuff like public key, Bob's public key, blah, 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 all that good stuff. Then we get the balance dropped, or sorry, then we add the key, the public key, to the contract by virtue of the contract account. So we are, in this test, we're basically, so this is like contract owner adding key for drop on server side. Okay, just a comment there. I'll leave that there. Then get Bob instance account instance for key pair. So this is actually an account. Bob is going to pretend to be the contract name, which means he can still ask for drop tokens because of this restriction. You know, the signer of the signing account ID will be the contract itself. It's just going to be Bob's key, Bob's access key. So the contract is basically sponsoring Bob to get these tokens via his key pair. Okay, so Bob basically goes and gets the tokens by calling drop. So he needs first a contract instance, then he calls drop with no args. Then we check Bob's balance. And remember, throughout this entire sort of experience, Bob just generated a key pair in his browser and had no near. So no near was required to do this. So let's also do this. All right. And remember, I don't need to deploy the contract, so I'm just going to do yarn test because all I changed was the jest test. I didn't change the contract. So I'm just going to deploy against the same contract. Probably not going to work. Oh, it did work. Well, happy about that. Let's do a test. Transfer dropped tokens. Okay, so Bob is actually going to transfer the drop tokens to, let's just transfer them back to Alice. Doesn't really matter. So we have Bob's account here. Bob should have the drop tokens. So the contract doesn't get updated in between the tests. So Bob, we need to get Bob's contract instance. Let's go all the way back to here, and then we need to call await contract transfer. And who are we going to transfer them to? Account ID. And then we just go Alice. Account ID, and then pay the gas on that. And then we got to go get someone's balance, but it's not the balance of the drop tokens based on the public key. It's the actual token balance. So Alice now has legit tokens. And this is going to be a lot easier if I just do. Whoa. Come on. Do, 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 do. Well, it all works out in the end, doesn't it? Okay, let's see if that works. So remember, at the end of this test, Bob has the drop tokens in the contract. We go get the contract instance based on Bob. And then we get Alice's account ID. We transfer to her. We get her token balance. So she actually has the tokens in the second mapping. And of course, it doesn't work. Tokens. Yeah. All right, so that was just a little naming issue. All right, let's see if we can do this. So anyway, yeah, after Bob transfers the tokens, they're in the final mapping here. Oh, looks like it worked. So they are now over in tokens. Okay, we have like 15 minutes to put a front end on this. Can we do it? I don't know. Thankfully, I have a bunch of stuff set up from before. So app tests are going to pass. Oh, no, but we still have to write a server for this. Server, I think we have most of what we need. But yeah, let's see. Let's just start the app. Also start the server. May have to edit the server. I might not be able to do all the fancy stuff that I claimed about, you know, Twitter and all that stuff. It's not gonna happen right now. Let me just increase that a little bit, increase that a little bit. Okay. Get new account, working on it. Let's see if we can get an account. Right, but contract.message is not gonna work there because our contract's all gobbledygook. So thankfully, init near has nothing to do with the contract. App has nothing to do with the contract. These are our state management things here. So this is like React state management is all contained in the state folder. The components are all broken up along the page. So basically implicit account and sell a message and sign in with your near wallet. That's from the example from live app review #1. So I'm just going to do a really crazy hatchet job on this contract thing here. And basically, I'm going to have to really hack up the whole thing. So once you have an account and you have an app key, the keys should still be working. So this is Bob. Bob has an account, a seed phrase, an implicit account ID, and some app key that gets added to the contract. Bob has no near. No near. These are the local keys. So basically access to all of this information. But I am in the contract. I'm in the contract component down here on this part of the page. So I'm looking currently at the old contract component. And to be honest, I can't really use any of it. So I'm just going to wipe the whole thing out. And I'm just going to say like social token drop zone. So I'm just going to redo that. And we shouldn't get any errors here. Are we still getting an error because of the mount? And then there's a wallet component, like a sign in with your near wallet. I think I'm going to get rid of that. Actually, no, I'm going to leave it. And I'll tell you why later. Okay, so we're quickly going to do a very, very quick implementation of this. Bob is this implicit account that has been created when you join the page. So you just, you don't have to have the account when you land on the page, but you can just create it in the background. Like all I did was press a button. So I can create a seed phrase, I can create an app key, I can add it to the contract. The server is doing that. We won't get into the server probably in this example. But basically now that I have an app key, this is a key pair that has been added to the application's contract as a access key, I can drop tokens to that key pair. So that's where I come into contract and got a lot of messy crap here. So I'm not going to load message. Just going to return if there's no local keys. Okay, fair. Oh, actually, that's super useful. I'm going to check balance. Check drop. So when the thing mounts and I get the access public, which is this key here, I'm going to check the drop. Oh, and remember those app tests we did? Aren't they handy? They are here. Get balance dropped. Okay. And because I've already changed the config, the app got loaded with the same config. So the contracts have all of that stuff. Anyways, so remember, get contract, create access key account. Boom. Okay. So now contract.balance. Let's do that in the try catch. Okay. So let's just log out the balance. If not, error there. What's the panic? What's a panic? What's a panic? Don't panic. It's going to be a bunch of, could be a bunch of crap, but we're not calling drop. Oh no, it's not going to panic at all. Okay, so we don't need to do this in a try catch really. So let's just do this. Let's keep it clean. Let's keep it simple. Okay. When the component mounts, let's check the drop. Public key is not defined. Come on. Give me a break. It's this. Oh. So we check the drop and the balance is 0. Okay. So then we probably want to put that into our balance dropped. We probably want to put that into our local state. Set balance dropped. Okay, so we're gonna make it. It's already a string, so let's just keep it as a string. Don't wanna mess around too much. We're just gonna pipe it straight into that variable. Who gives AF? Wrong use of that, but. Okay, so that should be going in there. Now let's go put balance dropped on the board. Dropped tokens to app B. Okay, we know what the app key is. It's the same thing. I'm not going to get fancy. Now we're going to create a button. Drop tokens, or let's make it fun. Let's claim drop. Okay. So on click equals, I hate all this stuff. Handle, claim, drop. Go up here. Handle, claim, drop. We don't need to have any inputs. Get rid of all this crap. Get the contract. Contract. I always get a new contract instance. I don't know why. I just like it. Makes me feel good. Drop. Gas. Await. Then check drop, which will update local state. Okay. Oh, it will panic, won't it? Drop will panic. Okay. So if drop panics, we do try, catch, and then we do if. Okay, and the condition or the panic is going to be. So if it's not this, let's throw that. And if it is that, let's do nothing. And let's just say alert. Okay. I'm pretty confident in this. Claim drop. Whoa! 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 Okay. Claim drop again. Wow! Whoa! Okay. I hope you're all as happy as I am. So we just claimed some tokens. We dropped some tokens to this app key. If we were a different user, we could get a different key, and then we could claim another drop. Oh my gosh. We're so many people. We can drop so many tokens. All right, now we have to be able to transfer tokens to an account. Okay, so we're going to do a handle transfer. Let's just do handle transfer. We need to get crazy. And let's do we're going to need a button and input. All right. Input value equals, oh no. Oh yeah, value equals count. Receiver, let's call it receiver. On change. Oh. That you don't target that value. Okay, we're all hooked up. That receiver now, but we don't have that as local state. Receiver, that receiver. Empty, that's better. Remember, the contract takes care of like how much to transfer and all that good jazz. So we should just check if set a receiver, turn. Okay. It's, a lot of people, they do all these custom modals, whatever. Get the functionality down. Get the validation right. Just do that first before you get all fancy. All right. So we're going to get the access key account. We are going to call transfer with the account ID. That's going to be receiver. That could panic in any number of ways, probably. Key not from app or no tokens. Let's just check for no tokens. No tokens, no tokens. Then we want to check drop, and then we want to check if we have receiver set, we want to check receivers. So let's do that as well. Balance dropped. Balance. Tokens. This is going to be a real hatchet job on the receivers just still in the input. So it's going to get a little hairy. Not going to be the best UX, but I'm going to have to wrap it up soon anyway. Account ID. Set balance tokens. Check drop. Yeah, just check the receipt. Doesn't matter. So the tokens should transfer from, they should go from like the app key with 100 to the receiver with whatever. Put another button and let's make that one check receiver. Receiver balance. Put some space here. Know what's going on. Okay, so the receiver's down here. So dropped. So receiver tokens. So this is the receiving account. So this should be the same person. So the person came to the website, had no near, clicked the button drop, got tokens dropped to that key, then at a later date chose to transfer the tokens to someone else. So again, are you going to use this exact pattern? No. Can you drop tokens to people that have no near? Yes. Can they transfer those tokens to somebody that also doesn't have near? Yes. So you could actually have the receiver not have any near as well, which could be also cool. So you can go to the near wallet, create an account, and at the funding step, when it says, hey, you should fund this implicit account ID, you could actually set that as the receiver of these tokens and send these tokens to that receiver based on the app key that you have claimed the tokens from originally. So we claim the tokens with the key, then we add the tokens, then we transfer the tokens to an account at a later time. Why? Because we can. All right, let's see if we did this right. Put another line break here, otherwise it looks ugly. So I claimed the drop and I got receiver tokens here. That's wrong. Why do I have receiver tokens? Get balance dropped. Oh, get balance tokens. And then, oh, it's probably just the balance. Okay. Let's set that as 0. Default is 0. Okay. So the tokens that are dropped are 100. We can't drop any more tokens to the key that we have. And then the receiver tokens are, I'm going to set it to my testnet account, SI1. So now using the app key, I am going to, I should move that button actually. That button is associated with transferring the tokens to the receiver. The input's underneath, but yeah, it is really bad, a bad UI. I don't know. Is that going to make it any better? Probably not. I'm just kind of thinking that this button doesn't make any sense here because of this, but let's just do it anyway. So we are going to call transfer. Oh, and it did. So yay! So the drop tokens to the app key are 0 and the receiver tokens are 100. So let's see if we can claim another drop. Did we find a flaw in the contract? We sure did. So I just claim drop tokens all day long and it drops to the receiver. What is it doing with the receiver? It's wiping out the balance. Oh boy. And it's just setting the balance of the previous person. So it's not actually adding to the balance. So that's probably a problem. So instead of adding to the balance, we probably want to go get the balance. If we wanted to make this proper, which I'm going to wrap up now, if we want to make this right, we would have to get the balance of the tokens map, and then we would have to add the balance of the drop tokens to it. But right now we're just basically taking the drop amount and we're copying it over top of the other token amount. Why is this cool? Because basically, let's use another receiver. So I can, let's just log out here of this account. So I can come to an app. I can get like a full, to be honest, a full-blown account. I can actually set myself as a receiver. I can get a full-blown account, and then I can get this app key. Now the key is the app key. The app key is added to the contract. The contract will let the app key call the drop method, which is here. So claim drop, to which you will get 100 tokens for that key. And you can't get any more until after you transfer them. But that's a flaw. So basically, we have to store, somehow in the contract, we have to store, used keys or whatever. And then also on your server, you really, really should map a public key to a third-party identity. So for example, an OAuth flow with Twitter. So you should sign up as a Twitter developer or whatever. You should get the OAuth flow. You should force the person who's getting this app key in their local storage to sign in with Twitter or some other service. Then in a database on your backend, store those two: public key, the key that claimed the drop, plus the identity. And that's so that you know that they're a real person and you get something out of dropping the tokens, right? So again, we do have a server and you can do that. So when you add an access key here, all you have to do is basically take this public key and store it somewhere with some OAuth flow. So you would add some middleware here, like, OAuth Twitter, and you would create a method, like a little middleware method, like has access key, that would check and get their Twitter ID. That's up to you. I didn't do that in this example. But getting back to the app, so they have the public key. They can only claim 100 tokens. Otherwise, it says tokens already dropped. And then if at a later time they have this account ID, they can set themselves as the receiver and they can come back to the site and they can transfer their drop tokens. So they can go get their Near wallet account ID later and then transfer their tokens to this page. So I will prove to you that this works by reloading the page, putting in that exact account ID and checking the receiver balance, to which I got 100 tokens. So I have tokens, and neither this account based on this seed phrase, so this implicit account ID based on this seed phrase, nor this app key that originally claimed the drop had Near to begin with. No one had Near. But we just claim tokens from a social token drop, which your server should definitely verify that the person is real and they should only be given one app key. We claim those tokens with the app contract paying the Near. Then we transfer those tokens to someone else, this implicit account ID that doesn't have Near. Like if you go and try to log into this account, it doesn't have any Near, so you can't. So you could go to the Explorer, accounts, and there's going to be nothing here. So there's nothing here, no transactions. So this account ID has no Near, but it has tokens. So that's cool. So nobody had any Near. We just onboarded users. We just gave them a social token drop. All right. I think that's it. I hope you enjoyed and didn't have too much trouble following along. If you have questions, you can always reach me and any of the other wonderful Near developers in Discord. And our Discord is, I better check. I think it's like near.org/chat. Nope. So it's chat.near.org. Nope. So go to near.org, join our Discord. It should be down here at the bottom. Where? Come on, guys. Okay, well, you can all laugh about this. Maybe under community? There it is. Yay. Okay, so go to near.org/community, shows how much I know, and join our Discord or Telegram. To be fair, you can find me more often on Discord. And yeah, there is a lot of ways to get involved. You can contribute You can lead a guild, which is basically like kind of a like a sort of a narrow kind of market vertical focus on building on near. So for example, um, people who want to build like SaaS products on near, or new discuss like new Web3 business models, or how to sustain open source software. So you can lead a guild, find events, stay in touch, build on near. So check it out and join up, and we will talk to you soon. Thanks for watching.